So we begin with the file name statement. File name statement gives a link to an external data file. Such statement can then use the alias to refer to the external file. If only the file name is given, then SAS will search for it in the default directory. If you are, for example, if you are going to read a file not in the default directory, you have to write the full path of it. You can always assign an alias to a file, which may or may not exist. If the alias is going to be used in the info statement, then this inf file must already exist in your directory. Otherwise, it will report error message. Homework is already put into the assignment. Both of them will be due next Tuesday. There are several different options inside the info statements. Typically, it will have 4 different options. The delimiter options is useful for files whose fields are delimited with special characters, for example, commas, semicolons, instead of spaces. One very common file is the CSV files, which is always split into different variables by commas. The due date is, I think it's next Tuesday in October. You can always look for it in the assignment part. Now we proceed with the first observation options. The first observation options always tells us to begin reading at a given line, and the observation options tells SAS Studio at which line to stop reading. Misover lines tells us not to go to the second line for the remaining variables when there are missing values. To be explicit, when the misover option is chosen to be true, then when you encounter a missing value in a certain line, then the SAS Studio will always skip that line and move to the next. Now let's look at the first example, which is syllabus will be uploaded later. Now we begin with this toy example of creating a SAS dataset from external data source. We always start with the file name statement and followed by the file name and the file path. Always remember to use your own directory path, file path here. And we start with the data step with the dataset name of age, and also begin with info statement and a roster as a file name, which is the same here, and followed by the delimiter options. Because the file here is somehow split by commas, then we proceed with the input step. Submitting homework is through the Canvas system. The second example is about how to use the first observation and the observation statement. The file name statement is same as before, and also the data step. The info statement is also the same, but with these 2 different options. With first observation as 6 and the observation as 4, which means when we are trying to loading resources from this file, we reading it from the 4th line to the 6th line in our SAS program, and we also follow it with an input statement. Now we would like to move on to the put statement. Typically, the put statement is used to write information to the log window. We also start with a data step with an input statement and with the put statement, which output these three variables to our log window and also some kind of summary reports in our log window. This is a very easy example. I won't talk too much about that. So put statement is also very useful when we are trying to output an existing SAS data set to an external file. The file name statement, the file statement, and the put statement are all needed for writing to an external file. When outputting an existing SAS file to an external file, we should also start with a file name statement, denoting the name of the data we would like to output, and also the file path, which is also the external file we would like to write into. And we also start with the data step, the name of the data set we would like to output. Here since we also input it all together, we start with an input statement and followed by a file statement denoting the file we would like to output, which is also the same here. Now we follow it with a put statement denoting the three different variables we would like to output to our external file. That is, we output all those three lines to the text file here. Here are some notes on how to use the put and the file statements. The file specified in the file name statement may or may not exist. If it doesn't exist, then it will be created, and then it will be created in your working directory. Otherwise, the old file will be overwritten by your new file. For example, if I already have a new text file in my directory stat390, then we will overwrite the original new cache text file with these three lines. File statement is always a complement of the infile statement. And always remember, file statement and infile statement must be preceded by a file name statement. That is, if you look back to our three examples, we always have the file name statement first, then we could have our data step. Put statement cannot appear in a procedure step. It should always appear in a data step. And put statement is also the complement of the input statement, and they share many common formatting commands. It is unnecessary to specify the variable type, whether it is numerical or character or not. So no $sign is required if you would like to use the put statement. Just look at here. Our bank variable is a character value, but we do not need to include a $sign here. But for the input statement, we have to put a $sign behind the bank variable, since it is of character value, but it is not required in the put statement. You can see the difference here. The next part is about reconstructing new SAS data sets. First things first, let's take note of some important facts. An existing SAS data set cannot be changed. Rebuilding a SAS data set is only accomplished by creating a new one. An existing variable cannot be modified. Modifying a variable is achieved by creating a new one. You can see the difference in the following examples. Here about on reconstruction of new data sets, we will discuss how to copy from an existing data set, which we will use the set statement. We will also talk about how to modify variables, which include three different parts: how to create new variables, how to delete existing variables, and how to rename existing variables. We will also talk about how to select a given subset of a data set. And the final part is about how to combine several different data sets into one. First, we would like to we'll talk about how to copy an existing data set, where we will use a set statement. First, we have to create a data step with the name of your new data set, and we also use the set statement where you have to set your old data set. Here is a very simple toy example. We create a new data set called age copy, and we set the old data set called age. Here, the age copy data set is exactly the same as the old age data set. So if you do nothing after the set statement, you just copy a new copy of your old data set. Now we'll talk about how to modify variables. Modification of variables is much similar to copy an exact copy from an existing data set. So we also have a set statement after your data step with your data set as your new data set and set your old data set, and which is followed by some other statements. Sometimes we need a transformation of the original data set, especially when we need to include new variables or create new variables from existing ones. We would like to delete some kind of variables. Sometimes we may need to copy data from an old data set and then add this to a new variable, which is somehow a mathematical function of the old variables. All usual mathematical operators are included in the subsystem. For example, plus minus, multiplication. This one is power, and also some log functions, exponential functions. This one is the square root functions. This means the square functions, which is very special compared to the power function. The mean function, sum function. This one is the absolute function. These two are the trigonometric functions. Later I will put a whole file about all the functions you could find in the subsystem. Typically, all frequently used mathematical operators will be included in the subsystem. Sometimes, if you encounter with some difficult functions, you may search for the menu block, or you can write a simple function, which is, I think this is somehow beyond the scope of this course. If you are interested in writing your own functions, I will send some kind of links in the file section on the Canvas system. Now here is our first example about how to create a new variables from a given data set. Here we first input our data set, which is called the students. We will input 5 different variables: student ID, the student's gender, the student's school type, which is of character value, the student's reading score, the student's writing score. Here we would like to create a new variable, the total score, which is the sum of the student's reading score and writing score. So here we create a new data set called students1, and we write the set statements with our old data set, the students, and we write another line of total equals read plus write. And always remember to put this small symbol here. Otherwise, it will return some errors. It is obviously very simple. There is always a different method to include new variables other than your inputted variables. Here you can adds a new variable in one data step. Someone asked about the difference between the double star and the double star and the 2. The double star is a power function, and the double star 2 means the power function with the power s2, which is a square function. The power function and square function. For example, if you like to get for example, a simple number with 3 power, you have to use like 8 star 3. And if you just like to use the square of the number a, you just type in a star 2. So star 2 is the power to 2. It's just a square function. Now we followed about different method of creating new variables in one simple step. First, we create a data step with our new data set students 2. The input variables is the same as the previous one. Also the 5 variables about the students. And we just add a statement total equals read plus write directly after the input statement and begin with our data lines and our inputted data. So this procedure from here to here, and also for this procedure, will yield to the same data set. The results will be shown in the YouTube link I shared in the Canvas, which will show how the results will look like if we use these 2 different procedures. But exactly, they will yield to the same thing. But the second method, you just need to write fewer codes. So I will recommend this one. Now we'd like to talk about the if-then statement. I think anyone with some kind of background in programming will be familiar with the if-then statement. And so it is also the same with SAS language. We also have if-then, else, if-then, else, if-then, else, which is very simple logics. The if statement allows using different definitions for different subsets of data set, which also use the same format as in other programming languages. So let's begin with this simple example. If you would like to create a new variable in the original student data set, which is called the read grade, if the student has a score greater or larger than 19, he or she will be given letter grade A. And also we have these different letter grades. So after we create the data step with our new data set named student 3 with the same set statements. And now we move on to the if-then statement. I think it is a quite simple logic. We write the conditions here. If the reading score is greater than 19, and we followed by a then statement, which give A to the student's reading grade, which is also our new variable. So all this followed as the first one. Somehow you could also use an else if statement. For example, after your first if statement, you can type in else if the student reading score lies in 18 to 19, then the reading grade will be B. And also else if here, and here we change it into else. And we can neglect this condition here because the students, there's no other conditions for the student reading score. It always lies in between like 0 to 100. And this example tells you that you can create the total and the total grade in one data step. If we look at our previous examples, we only add one new variable to our existing data. However, you can add 2 new variables all together in one data step. Here is the example. we create a new data set called student4 and also set the student data set as before. We first create the new variable total, which is sum of the students' scores. Then we follow it by a new different if statement, and we create a new variable called the total grade. Here we can see in this data step, we create two new different variables. In our new data set students4, we add a total variable and also the total grade variable to the old data set. So in the previous example, we only add one, but indeed you can include two new variables in one data set. So if possible, you can also like include 3 or 4 different variables in the same data step, which always allow you to do this. The next one we'll move on to how to delete variables from an old data set, where we will use a job statement and the keep statement. Job statement allows you to delete variables following the job keyword and keep all the remaining variables. If we write the job statement followed by variable 1 to variable n, then all these variables will be deleted in the new data set compared to the old one. The keep statement always do variable selection in an opposite way. The keep statement allows you to keep variables following the keep keyword and delete all the remaining variables. So if we write a keep statement with variable 1 to variable n, that is, you only keep these n variables in your new data set from the old one, and all the rest variables will be deleted. Always remember, you can not use job and keep statement in the same data step. That is, if you write a data step and then you write a job statement and a keep statement, it will return some very bad warnings. Here is a very simple example about how to use the job and the keep statements. First, we have to create a new data set called the student's job. We also set our old data set called students, and we would like to drop the read variable. And secondly, we create a different data set called students keep, where we still set the old one, but we keep the other 4 variables. So if we run those 2 different data steps, and we look at the 2 different new data sets, the students job data set and the students keep data set, it will have the same variables because we only drop the read variables from the old data set, but in the students keep data set, we keep all the rest, but we do not keep the one to be dropped. So these 2 data sets, students job and student keep, will always be the same. Now we would like to move on to the rename statement. It's about to change the variable name from an old name to a new one. Here is a very simple toy example. We create a new data set called students rename, and we also set the old data step, and we rename the old data set, old variable read, at read minus score or some, here should be right, read minus write, where the reading score is changed into the difference between the reading score and the writing score. Renaming. Typically, we do not use rename statement very often, but it is very simple to use. So we do not have to worry too much about the rename statement. Next, we will move on to how to select a subset of a given data set, which we also use the if then else statement to select subsets. Here is a very simple toy example about how to use the if statement to select a subset of a given data set. Here we use a data step to create a new data set called the girls, and we also set the same students data set. And if we write the if sentence with if female is 1, we will include only the observations where the students are female in our new girls data set. So if you run this chunk of code, you will find out in the girls data set only the female students' observations are included. Now we will talk about how to one data set into two. Here we would like to split the students data set into the boys and the girls subsets. We also start it with a data step, but here we will create two new data sets, which is called the boys and the girls. If you look at the previous examples, we only have one new data set after the data step statement, but we can always write several new data sets after the data step statement. Here we create two new data steps, and we still set the old one. So if the female is 1, then we output this line of observations to the girls data set. Otherwise, we output it to the boys data set, which is quite simple. We have to use the output statement here to denote which data set to be outputted. So we run this chunk of data. We could see that all the female observations of the students are outputted into the boys data set, into the girls data set. Otherwise, it was outputted to the boys data set. Now we have to move on to how to combine different data sets into a new one. We always combine data sets using after a procedure step. So before we discuss how to combine in data sets, let's first look at useful procedure, which is called the sort procedure. Sort procedure tells us how to sort the data according to the order of one or more variables. Which the general form looks like this. We begin with the procedure step, the procedure name, the sort, the old data set to be sorted. Here we call it the data set 1, and the data set to be outputted. We write the the name of the new data set 2, after the out keyword, and always to remember to add the no duplicate key. Somehow the function of it is somehow very complicated, but it could always prevent your SAS to yield some very bad warnings. And we can group the variables, group the data set for variable 1 into a descending order of some variable 2. You can also write ascending here. Then the variable 2 will be sorted in an ascending order. Here it will be sorted into a descending order. Here are some notes about the sort procedure step. The variables listed in the by statement are called the by variables. In a sort procedure, the dataset is sorted according to the values of the by variables. If there is only one variable, then the dataset is ordered according to the values of this variable. If there are multiple bivariables, the dataset is first sorting according to the first bivariables. Then that list is further sorted by the second variable within the categories of the first variables, etc. The optional keyword descending or ascending tells us to sort in a descending or ascending manner for the variables comes after the descending or ascending keyword. Two options are often used for procedure sort. The data equals what indicates which dataset to sort. The output keyword indicates the name of the sorted dataset. If the name is omitted, the original dataset will be replaced by the second one. So if we omit the out statement, we just sort the original dataset directly and return the sorted dataset into the old one. The optional no duplicative key option deletes the duplicate observations with the same values of bivariables. Now we look at this example. Here we input a marine data set, which include three different variables: the names of the marine species, the family of the species, and also the length of it. Now we perform our sort procedure. The data here is followed by our old data set, the marine data set, and we output it to a new data set called the C-sort data set. And we group them by family in descending order of the length. So if we run this procedure, we first come with the whale family, comes first. Then it will followed by the shark family, and within each family, the species are ordered in a descending order in their length. So if we run this procedure, the whale family will come first, with blue whale, the longest one, as the first, and then gray whale and the gray whale comes the second, which lies in the whale family with the second longest length. Then we will have like the killer whale. Then will come like the sperm whale and the killer whale, and then the next observations will be in the shark family, with the shark species having the longest length comes first, and the shark species with the second longest length will come the second in the shark family. The exact result will be included in my YouTube video. In the link I put in the announcement. You can also search it on YouTube. Now we'll see how the sort procedure is. We'll see the importance of the sort procedures when we are going to combine two different data sets. First, we have to type in two old data sets, the year 1998 and the year 1999 data sets. The year 1998 data set have three variables: the name, which is a character value, the temperature, the weather, and the year 1999 data set only have two variables: the day variable and the temperature variable, which is the same as the year 1998 data set. There are always 4 ways to combine data sets in SAS. This is just typical names, so you do not have to remember the names of the ways to combine data sets. Just remember, we always use two different statements: the set statement and the merge statement. So one combine two different. The first way of combining two data sets is to use the set statement. We begin with a data step with our new data set named combined one, and we set two different data sets as I mentioned before. We use a set statement followed by the dataset names. The number of the observations is the final data. The final data set is the total number of observations from each of the individual data set. That is, in our combined one data set, we'll have like 1, 2, 3, 4 plus 1, 2, 3, 4, 5. It will have 9 observations in our combined one data set here. When we are using the set statement, the observations in the first data set is listed read first, followed by the second, and so on. The final data set will have all the variables from individual data sets. Variables with the same name will be listed only once. So in the combined data set, where we just simply write the set statement with the names of the two data sets to be combined, we will have 9 observations, but with 3 variables, like 1, 2, 3. Here, the variable names are the same as the year 1998 data set. We'll have a new data set of 9 observations with 3 variables. But we can see that in the year 1999 data set, we do not have the weather variable. So in the combined data set, the same line of data will be written, and the weather variable will be indicated as a missing value. So the interleaving method of combining different data sets is that when we suppose we want to see the weather reports for year 1998 and year 1999 ordered by date, that is, we want to see all available data for January the 1st, then all the data for January 2nd, etc. We will first begin with the procedure, begin with the sort procedure step. That is, we first sort the data set year 1998 using the sort procedure step, and we sort them by day. When we also sort the data set year 1999 also by day, then we created a new combined data set which we call combined 2, and we also set the already sorted data set year 1998 and year 1999, and we combine them together by day. So in the new combined 2 data set, the first line of the data set is this one. Then the second line of the data set is this one. And here is the third line. The third line is this one. And this is the fourth line. The result is also shown in my YouTube video, which you could check later from the link. Now here are some notes on using the interleaving method to combine different data sets. Always remember to use a statement with a by statement. Interleaved data set has the same number of the observations as a concatenated data set, but the order is somehow different. For example, in our combined one, the data are ordered in this order: the first one, second one, third one, fourth one, and the fifth one will be in the second data set we combined. However, for the interleaving method, the order of the observations will be like this: the first one, the second line, the third, the third, and the fourth here. In order to use a by statement, each individual dataset must first be sorted by the same variable. When an observation from the first dataset has the same bivariable value as another observation from the second dataset, the one from the first dataset is listed first in the combined data. Uh, you can see, you can understand how these two different methods work um, in my video link I put in announcement. The next method is to use the one-to-one merge method to combine different data sets. Suppose you want to merge the first observation from dataset 1 with the first observations from dataset 2, the second with the second, all the way to the end of the dataset with more observations. We have to create a new data called combine 3, and we use a merge statement. It's a merge statement followed by the two different data sets, year 1998 and year 1999. Here are some notes about using the merge statement. You couldn't use a merge statement together with a by statement. That is, you always use a merge statement without a by statement. The number of observations in the final dataset is the same as the number of observations in the dataset with the most observations. The number of variables in the total number of variables in the dataset minus the number of overlapping variables. If two variables from different datasets have the same name, then the variables from the second dataset will replace the values from the first dataset. For example, if we write our data step with a new dataset called combine 4 and the merge statement followed by year 1998 and year 1999, which we sort by day. And the final dataset will look like this. We merge the first observation from the dataset year 1998 with the January 1st observation from this dataset year 1999. And always the latter one, the first one, will be overlapped by the second one. That is, we will have January the 1st with temperature 25 with weather sunny. And the second observation will look like January the 2nd with temperature 20 and sunny. And we move on to the January 3rd observations with temperature 35 and weather cloudy. And then we will have the observations of January the 5th. The next line of the data will be January the 6th with the weather variable as missing value, and then the January 8th as our final line of the data. If we follow this combination method. About match merge, there are several notes here. We always use a merge statement with a by statement. Do you mean this slide? This one, we begin with a merge statement and a by statement. If you write in this way, and we'll look at the combined data set. We'll have only one January the 1st observations with the temperature as 25. The variables from the second data set will overlap the first one, but we'll still keep the weather weather observations from the first data set. Here are some notes about how to use match merging when combining different data sets. We should always use the merge statement with a by statement, and the individual data sets need to be sorted according to the by variables first. That is, even we use this one, we have to perform these two procedure steps first to sort our two different data sets. Observation with the same value for the by variables are merged in the same way as the one-to-one merging. The final data set contains all variables from each of the individual data sets. If a variable appears in both data sets, the value from the second data set in the merge statement will always replace the value from the first one. There might be some missing values in the final data set. For example, when there are variables that appear only in the first data set, but for the particular by-variable value, only the second data set has a corresponding observations. You will understand this better if you watch the YouTube video link. It will show the results of all these steps. Also, the codes I will the codes of the examples I will also put into the file section on Canvas. You should always try those data steps in your own Studio to help you understand the statements better. Here's all about today's lecture. The second part of this lecture is put in the link I put in the announcement. So if you like to see the results of all these different codes, you should watch the video link I sent in the announcement on Canvas. You can also search for it on YouTube. You can follow my account. Okay, here is all for today's lecture. Thank you.